Hi, hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for continuous support and encouragement for creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of a video in the public domain. And I would like to thank Almighty for my good health and broad mind, and my friends, followers, my dear students and subscribers. Now, the today's topic of interest is moment of inertia. First of all, I will give you a glimpse in the moment of inertia. First, what is meant by an inertia? An inertia, simply we can say it as a resistance. Inertia means resistance. It is a property of a material, moreover. Moment of inertia is the property of the material in which the mass and the area, based on the mass and the area, the resistance towards moment varies. According to the distribution of mass and the area in a body, the resistance may differ. So this is called as a moment of inertia. You can simply say moment of inertia. Inertia means resistance. Moment of inertia means resistance to the moment. That is the simple in terms. So let me go to in detail. The moment of inertia is will be available for all the bodies have a definite shape or indefinite shape. Also we can calculate the moment of inertia. The moment of inertia is categorized by two types. One is area moment of inertia and mass moment of inertia. I have mentioned here mass moment of inertia and area moment of inertia. So mass moment of inertia, let me define that. A body offers resistant force against linear motion, or we can say it as a reaction against static body or linear motion. This is called as a mass moment of inertia. Whereas the area moment of inertia means a body offers a force against to the rotation. Against the rotation, if the resistance against the rotation means it is called area moment of inertia, and it depends on distribution of area and distribution of area to resist rotation motion. Therefore, this area moment of inertia, the unit is meter power 4, whereas the mass moment of inertia, the unit is kg meter square. Kg meter square. Okay. So the mass moment of inertia is the property to resist rotation, and it depends on distribution of area to resist linear motion. So that is called as a mass moment of inertia. And next one, the important concept is a radius of gyration. Whenever we are talking a moment of inertia, this radius of gyration should come into picture, because the relation is when I is equal to a into k square. So this k is equal to square root of I by a. This k should always be minimum. The radius of gyration can be defined as the distance in which the entire area is placed such that the moment of inertia is equal to moment of inertia of the actual body. So that is called as radius of gyration. So the entire area should be placed such that this moment of inertia is equal to moment of inertia of actual body. So this will be given as the radius of gyration. The radius of gyration should always be minimum. The radius of gyration, if it is for the area moment of inertia, the k will become square root of I by a whole square root. And if it is for the mass moment of inertia, the k is equal to I by m, the square root of I by m. So that I have mentioned here. Okay. Next, the moment of inertia is governed by, the inertia is basically governed by two theorems. One is a parallel axis theorem and another one is a perpendicular axis theorem. Where parallel axis theorem, we consider, we get only normal moment of inertia. If it is the perpendicular axis theorem, we get the polar moment of inertia. So here, the perpendicular axis theorem, the Izz is equal to Ixx plus Iyy, whereas this Ixx and Iyy are found out using the parallel axis theorem. Therefore, Ixx is equal to Igg plus Ax square and Iyy is equal to Igg plus Ay square. Here, x and y are the centroid point in the x and y axis. The distance from the origin to the centroid axis in x and y direction, that is called as an uh, x and y. So Igg is the inertia, moment of inertia. And here I would like to give an example how the perpendicular axis theorem will come. The polar moment of inertia is mainly for the shaft kind of things. For the shaft, Ixx is equal to Iyy, Ix is equal to Iyy, that is equal to pi by 64 capital D power 4. Therefore, Izz is equal to 2 into pi by 64 capital D power 4. Therefore, this kid strike it out. We will get Izz is equal to pi by 32 capital D power 4. So this is the polar moment of inertia of the shaft. How we get the, by means of moment of inertia of the shaft? As simple. So this is the uh, example of how the polar moment of inertia is converted in normal inertia is converted into polar moment of inertia. And I have faced a question like this: if a shaft is like this, okay, here we are, sorry, here we are getting a fixed axis and the shaft is subjected to a point load of here and a torsion load moment is here. If the mass moment of inertia is coming to picture, when the point load is acting, the shaft tend to bend like this. Whereas the polar moment of picture, polar moment of inertia come into picture when the shaft is rotating like this. How we can relate these thing, both parallel as well as the mass moment of inertia and area moment of inertia, is means by means of the perpendicular axis theorem, that is is equal to Ixx plus Iyy. So this is the question I was getting from my interview. Two of interviews I have get these things. The first interview I didn't answer that, but the second interview I have answered that. So this is a very very important question. So we have to notice this. How the Cartesian coordinate is converted into polar coordinate by me is the question means, by means of the perpendicular axis theorem we can convert the Cartesian coordinate into polar coordinates. That is the very simple question we can easily get from this equation. So don't forget that. Okay. Next, I would like to give some of the cross sections and the normal moment of inertia as well as the polar moment of inertia for your information. Here, the cross sections, circular cross section means, that is Ixx is equal to Iyy, that is pi by 64 capital D power 4, whereas Izz is equal to pi by 32 D power 4. For the hollow, it is similar. Ixx is equal to Iyy, that is equal to pi by 64 capital D power 4 minus small d power 4, where capital D is the outside diameter, small d is the inner diameter, and the polar moment of inertia is pi by 32 capital D power 4 minus small d power 4. If you may get an equation, you can see an equation like this: pi by 32 capital D power 4 minus a small d power 4 divided by capital D. This equation will not come. This is the wrong equation in order to get the hollow section polar moment of inertia. Please beware of this. And for the uh, square section also we have ixx is equal to iyy. In the shaft we can use either square or a rectangle or a circle. That is why both three sections I have given izz. The rest of the sections won't be considered for the perpendicular axis theorem. For the square, ixx is equal to iyy, that is equal to a power 4 by 12, whereas izz is equal to a power 4 by 6. In the rectangle, ixx is equal to bh cube by 12, whereas iyy is equal to hb cube by 12. The difference is the square all sides are equal. We know that the square all sides are equal, whereas for the rectangle it may have an orientation like this or it may have a orientation like this. That is why when this is the thing, this is the case, this is for iyy, this is for ixx, this is for ixx, and this is for iyy. Okay, for this the polar moment of inertia is b into h into b square plus h square divided by 12. Next, it is for the triangle. Triangle, it is bh cube by 36 and ixx is equal to bh cube by 36 and iyy is equal to hb cube by 48. For the semicircle, ixx is equal to 0.0068 d power 4 and iyy is equal to pi by 128 d power 4. For the quadrant, 0.055 r power 4 and iyy is equal to pi by 256 d power 4. I'm going to give some of the mass moment of inertia of some bodies. First, mass moment of inertia of a disk. This disk and sphere we can see in the flywheel. On the flywheel, I theta, where we have taken care of this I, mass moment of inertia. Therefore, disk I is equal to mr square, whereas a sphere, for the sphere, mr square. Disk mr square by 2, for the sphere mr square. For the cylinder, I is equal to 3 by 2 mr square. For the thin ring, I is equal to mr square. This thin ring as well as the disk are considered for the flywheels. So please make a note. For the thin ring as well as the sphere, the formulas are same. mr square, I is equal to mr square, where the disk I is equal to mr square by 2. For the solid sphere, it is 0.4 times of mr square or mr square divided by 4. Mr square divided by 1.25, you can say. For the sphere cell 0.66 times of mr square, and the right circular cylinder mr square, and the circular wire which is again mr square. Next, we are going to discuss about two things. One is the centroid as well as the center of gravity. Both are very important because centroid, it is a two-dimensional plane. Centroid means a two-dimensional plane. The center of gravity of the centroid two-dimensional plane is called as a centroid, where the center of gravity is the for the three-dimensional body. Here, what we can understand is this: in the centroid, the area center is very important, where the CG, it is the mass center. So this depth you have to understand. The CG means it is for mass center. CG is the mass center, where centroid is the area center. And centroid, for the area we have only two dimensions, whereas for the mass we have a three dimensions called volume. Here I would like to give some of the CG formulas for different uh, shape. First one, we go with the CG of the hemisphere. Hemisphere is 3r by 8 for the solid cone h by 4, cylinder h by 2, pyramid h by 3, and hollow sphere r by 2. The centroid of the different sections are the centroids of the different sections are, so for the circle it is d by 2, square it is a by 2, rectangle it is either l by 2 or b by 2 according to the orientation. For the semicircle 4r by 3 pi. For the triangle a by 2 root 3. Isosceles triangle it is 4b square minus l square divided by b. And for the quadrant 4r by pi. 4r by pi. So here I would like to give a moment of inertia of a triangle. From the top plane it is bh cube by 4. From the CG it is bh cube by 36. From the base it is bh cube by 12. For the triangle, you please notice this, you have a three moment of inertias according to where is your reference plane is very important. If the reference plane is in the top of the triangle, then the moment of inertia is bh cube by 4. Where the reference is at the center of gravity, then bh cube by 36 or bd cube by 36. Where if it is from the base, it is bd cube by 12. That you have to understand. With this, I'm going to close the moment of inertia session. I hope that I have given the enough knowledge which I have know. So, if you have any doubt, please comment me in the comment section. Thank you. Thank you all.